Hi everyone, how are you all? Welcome to my channel Concept Learning. This is Rasigna. So in my last class we have completed 3D geometry, right? So we have nearly took 5 classes and we have covered most of the topics and most of the models of the sums and completed 3D geometry finally, right? So I have told you that we are going to start a new topic, and in my last class in 3D geometry I have left you all with a homework problem as every day. So uh, first, I'm going to teach that homework problem, and then I'm going to tell you what topic I'm going to start today. Okay, so I'll only tell the procedure how to do this problem. Let us look into it quickly and start the new topic. The point 2 comma alpha comma beta lies on the plane which passes through the point through the 2 points and is perpendicular to the plane. Then you need to tell what this relation is. Okay. So, what is it? I have a plane, and on this plane there are 2 points situated. So those 2 points are 3 comma 4 comma 2 is one point, and the other point is 7 comma 0 comma 6, right? And then he gave that uh, the required plane is perpendicular to this plane also. Okay, so there is another plane. This is perpendicular to this plane, to the required plane. Okay. So now, what do I need to find this relation over here. Right. So what all things I have, what all have I to find out? So first, to find that relation, I must substitute this point on the required plane. To substitute first, I need to find the equation of the plane. Am I right? So how do I find the equation of the plane? So I can clearly see that I have 2 points over here. So I can easily use the 2-point form, right? So how do I use the 2-point form? What is 2-point form? It is a into x minus x1 plus b into y minus y1 plus c into c into z minus z1 is equals to 0. So this is the 2-point form, right? Sorry, 1-point form, right? So in this, anyways, I know x1, y1, z1 because I have 2 points. I can take any 1 point, okay? But the thing that I have to find out over here is A, B, C. Those are the dias of the normal of the plane. Now I have many clues to find out that. So how do I do it? So if this is the normal of the plane, normal of the required plane. Okay. So now I have these 2 points, and if I join these 2 points, okay, if I join these 2 points, I can clearly notice that the normal of the required plane is perpendicular to that line when I join this 2 points, right? So if this is the normal of the required plane, I can think that the dias of that normal are a comma b comma c. Am I right? So here I can use perpendicular condition for this line and this line. This line's dias I can easily find because I have 2 points on that line, right? So after that, I also know the dias of the normal to this plane. These planes, because this is the plane which is perpendicular, right? So this normal dias also I know that are 2 comma 5 comma 0. Okay. So I can use perpendicular condition to this normal and this normal a comma b comma c. Then I'll get two equations. After solving those two equations, I'll get the values of a, b and c. Okay. So after knowing the values of a, b, c, I'll substitute in this. Right. So after substituting, what is that? I will get the equation of the plane. Then I need to substitute this point. Okay. Then I'll easily get the relation 2 alpha minus 3 beta equals to what. Okay. So I have told the complete procedure of this problem. You can try and you will definitely get the answer by following this procedure. Okay. So if you have done very good, well. So now this is the homework problem of yesterday. So that is it. Now, what is the topic that we are going to start today newly? So, that topic is nothing but differential equations, okay? So, we are going to start differential equations, which is an intermediate second year. which is very helpful for mains. Okay, so now let us start differential equations. Okay, so we are going to start differential equations today. So why did I choose to teach this topic now? I told you that I chose 3D geometry because many people feel that it is difficult but easy. Then why did I choose differential equations? Yes, differential equations is also very easy and some people feel it difficult. But the main reason behind me choosing this topic is because this topic not only helps for the students who are studying intermediate, but this also helps for the students who are studying degree, who are studying their engineering, and the other competitive exams that you are going to write for your future jobs. In that also differential equations is very helpful. It is a very useful chapter and it is very easy too. If you study completely the differential equations, if you read each and every part and practice many problems on those, then believe me, you can play with differential equations. Okay, it is such simple, but you need to look at every model very keenly and you must know how to do each problem in different model and how do we use those models. Okay, but believe me, it's very easy. So now let us start differential equations. Okay, so after starting this differential equations, I'm not going to stop this up to the inter level. I'm also going to go beyond that level, that is I'm going to teach degree and engineering syllabus of differential equations also. Okay, so this is helpful to all those students also, so all those students also can watch these videos. Okay, so now let us start differential equations part 1. Okay, so at first, what is a differential equation? So differential is something new to us, not very new, but we don't know what are differential equations, but we have studied too much about equations. What is equation? We are going to equate some two parts, that is LHS and RHS, right? So that is an equation. So what are differential equations? In differential equations also we are going to do the same thing. We are going to equate using some differential term. Now what is it? So if you have studied in intermediate differentiation, intermediate first year, if you take y is equals to 2x, some equation y is equals to 2x. Now if I differentiate this equation on both sides, derivate. So with respect to x, okay, with respect to x, okay, with respect to x, if I differentiate, what do I get? I get dy by dx is equals to 2. Am I right? Dy by dx is equals to 2. So now this is one differential equation. We are equating some two things and I have a differential term over here. So that is known as a differential equation. Okay, a very simple thing. So we need a differential term in that equation and you need one simple equation. That's it. That is known as a differential equation. Now in differential equation we have many terms to explain. Okay, so the first basic terms are order and degree. Okay, so first let us see what is the order of a differential equation. Okay, so now what is the order of a differential equation? Order of a differential equation is also a very simple concept. Let me take the previous example only. What did I get the differential equation after derivating y equals to 2x? I have got dy by dx is equals to 2. Am I right? Is this the differential equation I have got? Now, if I differentiate it on both sides once again, the second time, what do I get? I get d square y by dx square is equals to 0. Am I right? Now, if I differentiate it the third time, I get d cube y by dx cube is equals to 0. So, I can derive it many times. Now, what is the order over here? This thing is known as order. That is, how many times we are differentiating an equation is known as the order. Okay. So, here 1 is the order, here 2 is the order, here 3 is the order. Now, let us move somewhat complex in the complex form. Now, I am going to take an equation like d cube y by dx cube plus dy by dx is equals to 0. If this is the differential equation given or is equals to 2. If this is the differential equation given, then what will be the order? Here I can see that for this the order is 1 and for this the order is 3. Now what do I take the order of a differential equation as? Yeah, so here we will take 3 as the order of the differential equation. Why? Because in differential equations, if you need to find the order of a big differential equation, then you have to take the highest order of the whole differential equation. Okay, so here the order is 1 of this and of this the order is 3. But in the whole differential equation, the highest order is 3. So 3 will be the order of this differential equation. 3 will be the order of this differential equation. Understand? Very clear. So that is the order of a differential equation. It is a very simple concept and further after doing some we'll learn more. Okay. So now let us look into the second one, that is what is the degree of a differential equation. Okay. Let us see. So now let us see what is degree of a differential equation. What is it? So degree of the differential equation, we have a small definition for this, but first let us learn in a normal way. After that let us read the definition. Okay. So first, if I have a differential equation like this, see, I cannot say that always the power of the differential equation is 1, right? Suppose if I say this is d square y by dx square is equals to, plus dy by dx is equals to x square. Always differential equation cannot be in this form only. It can also be like this square. It can also be like this power 5 times. It can be anyways. The power may be anything, right? Power need not be one only. So now this thing is called degree of the derivative equation. The power of this differential equation is known as the degree of the differential equation. Understand? So now here I have 2 and I have 5 also. Then what do I take the degree as? If I have been given like this, dy by dx whole power something 2 is equals to some x square. Now I can tell that the degree of this differential equation is 2 without doubt. Degree is 2 over here without doubt. But here I have the power of this as 5 and I have power of this as 2. Then what do I need to take the degree of the differential equation as? So then we are going to use another point, that is here when we are discussing about degree, we are going to take the power of the highest order derivative. Highest order derivative, not the highest power, the power of the higher order derivative. Here I have dy by dx and I have d square y by dx square. Now which one has the highest order? Without doubt this has the highest order, right? This is 2 and this is 1. So this is the highest order. Now I need to take the power of this highest order. So I need to take the degree as 2. It may be 6, 7, 8 or 100. But this is not the highest order. So I am going to leave this. I am going to take the power of the highest order. Okay. Highest order's power I am going to take. It may be 1, 2 or anything. Okay. But I am going to take this power as the degree of the differential equation. Now, that is it. Now, if I go into some more complex part, if I say there's a differential equation like uh, dy by dx, this is in log dy by dx is equals to x square. Now what is the degree of this equation? No, you cannot tell the degree of this differential equation. It is undefined. Why? Because you can only define the degree of a differential equation which is in its polynomial form. You know what is a polynomial, right? You have studied it right from your 8th, ninth, and 10th. You have been studying all these years, even in second year, into second year. So, you know what is a polynomial? A polynomial is in this form, some x2, x square plus x plus 1. This is a polynomial. So, this is a polynomial, right? So, but will this be a polynomial? X power minus 1 is equals to 0. Will this be a polynomial? This one, this part. No, that will not be a polynomial because you cannot have the negative integers as the power of x. In a polynomial, you only need to have the positive integers in the power. Only then it will become a polynomial. And also the x, these x and all cannot be in logs. That is not a polynomial form. Okay. Why I am saying that? Because if you take e power x is equals to 0, will this be a polynomial? No, because it is in power. The x must not be in powers and the power of x must only be positive integers. Now if I take this will also give me the same thing. Okay, because I get, if I take log from here, I get dy by dx is equals to e power x square. So this is in e power, so that is not a polynomial. So for such form, the degree of a differential equation is undefined. A degree of differential equation is defined only if the differential equation is in polynomial form. Only if the differential equation is in polynomial form. Okay. So finally, if I need to define what is the degree of a polynomial, what do I say? The degree of the polynomial is the power of the highest order of a differential equation which is in polynomial form. Okay, which is in a polynomial form. So that is the final definition of a degree of a polynomial. First, I have told you how a degree looks. What are the conditions for it to be a degree and all that. And after that, through that, I have told you the definition of a degree. What is it? The power of the highest order derivative in a differential equation which is in its polynomial form. Okay, that is it, and that is the degree of a polynomial. Now if I give you dy by dx whole power 1 plus d square y by dx square whole power minus 1 is equals to 0. Can I write the degree of that polynomial? No way, because you have the power as minus 1 over here. For minus 1, it is not a polynomial form. So there is no degree for that equation. Okay. So now if I give you the equation like, look at another equation now. Dy by dx is equals to, dy by dx plus 5 is equals to d square y by dx square whole power 5 by 2. Now can I write the degree of the differential equation? Many say that some say if you are confused, you say that no, you cannot write. But you can write. Why do they say you cannot write? Because yeah, this is a rational form and so it will not become a polynomial. Then how do I write the degree of the differential equation? But you can slightly make some changes in this equation. That is, you can square on both sides. If you square on both sides, what will happen? Whole square, whole square. Then what will happen? This 2 and this 2 will cancel. Then I get differential equation as dy by dx plus 5 whole square is equals to d square y by dx square whole power 5. Now you can see the degree of this differential equation. The degree is 5. Absolutely 5. There is no doubt in it. So, first when they give you a differential equation, you must first look that if you can change it into a normal differential equation, into its polynomial form. You can change it or not. If you cannot change it, then you will write that the degree is undefined. But if you can change it, you must first change it into a polynomial form and then write the degree. Simply you do not write the degree of differential equation as undefined. Okay. First you need to check it if you can change it into polynomial form or not. Understand? So that is it for today. I have told you what is a differential equation, order of differential equation and degree of a differential equation. So in my next class, we are going to move into further topics and discuss more about differential equations. Much more interesting facts about differential equations. Okay. So like the video, share the video and subscribe to the channel. Okay. So for more videos, subscribe to the channel and share it to your friends and all, because this is also helpful for many sectors, not only for intermediate. So if you have any doubts, you can put in the comment section below. I'll definitely answer to your doubts, queries. Okay. So thank you for now. Meet you in my next class. Bye bye.